Okay, 3.6, we're going to talk about parallel lines, and we're going to use our transversals that we did before, right? And we're going to use all those lines that we talked about where we made the conditional statements in 3.5. We're going to write the converses for 3.6. So, if we have a conditional statement and a converse, we can see if the converses are true. So we're taking our theorems that we did from last lesson, and we're proving them as theorems that are converses to show that two lines are parallel. So last time we were doing proving that angles were congruent because lines were parallel. Now we're proving lines parallel because of the angles. Okay, so remember this and this are switched from last lesson, and they make parallel lines. So I'm going to draw a little picture right here. If we have corresponding angles, so that would be this one and this one. So if we have corresponding angles that are equal, congruent, then the lines are parallel. If we have two lines with a transversal and the angles are alternate exterior angles, are congruent, then the lines are parallel. And then the last one is same side interior angles, which are not congruent. They are supplementary. Then the lines are parallel. Okay, so here's some shorthand. Corresponding angles, congruent lines are parallel. Or converse of corresponding angles, lines are parallel. Okay. So let's do a proof. All right. That gave us that 2 and 3 are congruent. Those are, what are those called? Those are called alternate interior angles. Okay, so we know that angle 2 and angle 1 are congruent because of vertical angles are congruent. Okay. Then I'm going to do that, which means angle 3 is congruent to angle 1, and that is transitive property. And then the last thing we wanted to prove is that L is parallel to M, and I guess theoretically this is L and this is M, because those are two we're proving parallel, which makes sense. We're going to do converse corresponding angles are corresponding angles. Let's think about what I'm trying to say here. Converse corresponding angles, lines are parallel, which is this basically I just used for the end of my proof, which is also right here. Okay, so we just proved, oh, there it is. We have just proved the converse alternate interior angles theorem. If alternate, oh, I know what I was going to do up here. So when it says corresponding angles 1 and 3 are the corresponding angles. So the reason we started talking about corresponding angles is because 1 and 3 are corresponding angles. I knew there was something kind of I forgot right there. Okay, so we just proved converse of the alternate interior angle theorem. If alternate interior angles are congruent, then the lines that form them are parallel, and we'll do a little reminder. Alternate interior is here and here. So those are my alternate interior angles. Okay, so let's do some work on which ones. We're going to use those converses up at the top to see which ones are parallel. And let's start with they are not on here. I messed something up. Okay, so let's write angle 1 is congruent to angle 5. So find angle 1 and angle 5. Those are corresponding to, and these also came off. I may have to redo this worksheet. So hopefully these letters will be on yours. Okay, so let's talk about, those are corresponding angles. For J and K. So J and K are parallel. M is the transversal. And this is corresponding angles. Oh, converse corresponding angles, which is what's at the top of the other page. Converse corresponding angles. All right, the next one says, mine does, yours doesn't, or yours might, apparently. 3 and 13. So angle 3 and angle 13. So I need to change colors because we're going to do angle 3 and angle 13. So that's 3 and 13. Okay, those are alternate interior angles. Okay, and I guess I can write this on here. These are corresponding. So that means that M and P are parallel, with J being the transversal. And the reason is converse alternate interior angles. Okay, then the next one is angles 16 and 9. Oh, angle 16 and angle 9 are supplementary. So where's 16 and 9? Those are same side interior. So if that's true, then J and K are parallel, P is the transversal, and this is converse, same side, interior. Okay, so using the different angles that we know, we can use our postulates to figure out what lines are parallel. Okay, so we're going to do the same thing, but with a little bit less places to write it and know what we're talking about. Okay, G and H are parallel. So again, if you have those big fat arrows on it, that means they're parallel. Okay, and angle 1 and angle 11 are congruent. Okay, I want to know, I think J and K are parallel, but how would I prove that? Well, let's see. 11 and 7 are corresponding. So 11 and 7 are congruent, corresponding. I'm going to kind of do my own little proof here. And then seven and 1 are alternate exterior angles. I always put that little apostrophe. I'm probably not supposed to. Okay, so if 7 and 1 are alternate exterior angles, then J is parallel to K because of converse alternate exterior angles, but they're different ones, then no. Oh no, they're not. Okay, so once I put 7 in the mix of the angles, it all makes sense. And that